Okay, welcome to another problem session. So today is a day 2 and I'm going to do some problem from JEE exam. So it is JEE from India and this is 2024 physics paper 1. There are two papers and we'll get to that second paper later, but my approach, if you wanted to study more along those lines, you can just go to my website, and that is physicsbootcamp.org. Things you have to really type this to get there. All right. So here's a question. It's a kind of like a formula manipulation question. So if you remember some of the formulas, you can kind of manipulate them here and there and then get the answer even if you don't know any physics. This kind of crazy question. I don't like this kind of question, but here it is. All right. In this question, you'll have 4 choices, and any one of them can be all 4 right, 3 of them right, 2 of them right, 1 of them right, but there is at least one of them right in every one of these questions in this section. Okay, so it's rather simple because it is circular motion. So each one of the orbits, it's kind of like a hydrogen atom thing, okay? So you're looking at a particle in that orbit, and it may be like an nth orbit or something like that. But then I'm not going to put like E sub n, V sub n, R sub n, things like that, or L sub n. We're not going to do subscript. Just leave the subscript out. So here's the center. So the force has magnitude kr, k times r, and of course the acceleration, if it's a circular motion and it's got some speed v, that's also could come with a subscript, right? So v, then the acceleration will be pointed in that direction, and that will be v square over r. So there's one equation right away you can write down is m v square over r equals to kr. And so you can see over here, you can just multiply by r. It's going to be mv square equals to kr square. Another thing that they're looking is energy. So the energy will be simply kinetic energy plus potential energy, and v is the speed. It's not the radial speed, it's the speed. E equals to half mv square and plus half k r square. And I don't know why they just went ahead and gave you the potential energy formula, because when you have this, you expect potential energy to be that, right? So, but they gave you anyway, make use of it. You can see from here, I could write this as kr square, or I could write this as mv square. Just by using that, I can write energy this way. And third thing is, they even give you the Bohr's quantization rule, L equals to NH bar. So L is going to be R cross P for a particle, and this is just M. This is the only thing that you really need to remember as far as I can tell in this problem. So I don't know why my pen stopped working. So let me totally start working. Okay, it looked like my battery had died, so I changed my battery. So here, back to the problem. So this will be simply, this is MV, and you can see this MVR. So it says MVR equals to N H bar. So if you knew this, then you just basically plug in and solve the problem. Okay, so let's start from A. To check A, I have to get R squared somehow. So in here I can, you have an N itself, so you basically going to use the quantization rule. So I can, I'm going to get V squared there. So I can do the formula. So I can square both sides. So I square 3 and then use 1. So M square, V square, R square equals NH bar and H bar square. And so let's look at this one, 1M. So this part is just KR square. So this just becomes M K R square, and so this just becomes MK R to the power R square, because answer is R square, so I'm going to keep it R square. So this, with that, you can see R square, and R is positives, so R square will be positive, so I'm going to throw away the negative root. Okay, that's going to be N H bar over square root of MK, and here it is. So A is right, so that's one of them I got. Okay, so B, let's see, B is right. This formula they gave you, I can do the same thing. I'll just plug in over here. So V square equals K over M. R square is that, so that's going to be N H bar 1 over square root of MK, and you have K over M from here. So this K will become the square root of K, and this will be square root of M square. So it's going to be NH bar square root of K over M cube, which is also correct. So B is correct. Check the C. Is it L over MR square? So L over MR square. Check if that happens. Well, L is NH bar, and we have, if I do this MR square over here, so it will be M NH bar square root times square root of MK. So NH bar goes away, and so cancel this, it becomes square root here, and so the square root of K over M, which is also correct. So it's also correct. Let's check out D. Let's check out D over here. So E is one of these guys, so KR square. So, and this whole thing will be N H bar times K over square root of MK, and so you get NH bar square root of K over M. So there is this 2 that's not here, which means D is incorrect. So the answer is like A, B, and C. Okay, so that's you can see, if you're looking back, what is the lesson from this problem? You know, if you encounter something like that, where are you going to need to put emphasis on? And I'll say this is what you need to kind of remember, these 2 things. Everything else you would have seen someplace else, and even this one you have seen someplace else, but because you don't see this in the context of Bohr's atom, this is something you might not remember. So you can figure it out, of course, like I did over here, but this is the only, I can imagine this could stump somebody, but other than that, the whole problem is probably not worth the for the contest. But there it is. Okay. All right. I'll see you in another video. Bye.